Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. If you've watched the intro video on solving log equations, then you're ready to level up. Today, we're covering intermediate log equations that require a little bit more care and technique. So are you ready? Let's get into it. Here is our first question. So notice how the left side has a squared. But we can't actually apply the power rule here because the squared is squaring the entire left side. It is not squaring just the argument. So the power rule only applies when the exponent is on the argument, not the entire log expression. To solve this one, what we're going to do is we're going to square root both sides. So if we square root the left-hand side, we're going to get log base 2 of x minus 1. And then when we square root the right-hand side, we're going to end up with both a positive and a negative square root. So that is going to give us plus or minus 2. Next, we're going to use the definition of a log to rewrite this into an exponential equation. So we get 2 to the power of plus or minus 2 is going to be equal to x minus 1. And now we're going to split this up into two cases. So if we have 2 to the power of positive 2, that's going to give us 4 is equal to x minus 1, which means x is equal to 5. And for the negative case, 2 to the power of negative 2 is going to give us 1 over 4, and that's equal to x minus 1. So therefore, x is equal to 5 over 4. And again, just double check to make sure that your solutions here are valid. So if we substitute 5 into our original equation, we're going to get log base 2 of 5 minus 1. And 5 minus 1 is a positive number, so we're good. And same thing for 5 over 4. If we substitute in 5 over 4, we're going to get log base 2 of 1/4, which again, we have a positive number as an argument. So both of these solutions are valid. For this question, notice how we have different bases for the left-hand side and the right-hand side. So that gives you a hint that the change of base rule is probably a good strategy here. And that's exactly what we're going to do. And it doesn't really matter which one you decide to change. We can either make both sides into log base 2, or we can make both sides into log base 5. You're going to get the same answer. So let's actually go ahead and make everything into log base 2. So now the left-hand side is going to be log base 2 of x over log base 2 of 5. And then our right-hand side stays as 2 over log base 2 of 5. So now notice that if we multiply both sides by log base 2 of 5, the denominator is going to go away. So we end up with log base 2 of x is equal to 2. And now we can go ahead and use our definition to rewrite this into 2 to the power of 2 is equal to x, which means x is equal to 4. Double check that it's a valid argument, and it is. So therefore, we have x is equal to 4. So for this question, we have invited our friend Composite Functions back. If you're not familiar with composite functions, make sure you check out the composite function video. So here we have three functions, f, g, and h. What we're doing is we're putting h into our function g, and then taking that and putting it into the function f. So our function h is x minus 1. So we start with x minus 1. That goes into our function g, which is log base 2 of x. So that becomes log base 2 of x minus 1. And then we're taking this as input and putting it into our function f, which is log base 3. And then this is our input. So this is our composite function f of g of h of x. So this is equal to 1. So notice how we have a log inside a log, which means you're going to need to use the definition of a log 2 times. For the first one, we're treating this entire thing as the input. So using the definition of a log, we're going to get 3 to the power of 1 is equal to log base 2 of x minus 1. So now 3 to the power of 1 is just 3, and we can go ahead and use the definition of a log again, and this time we have our argument, which is x minus 1. So then we're going to get 2 to the power of 3 is equal to x minus 1. So that means we're going to end up with x is equal to 9. Double checking to make sure our argument stays positive, which it is, so this here is our final answer. So for this question, again, we have a term where the power rule doesn't apply because it's the entire ln of x squared. So whenever you see something like this is actually a hidden quadratic equation. So in order to make things look a little bit simpler, we're going to actually use substitution. So we start with letting u be equal to ln of x. So that means we can rewrite this as u squared minus 3 times u minus 4 is equal to 0. And now we can solve this by factoring. So this is going to be u minus 4 times u plus 1 is equal to 0. And we get two solutions for u, which is u is equal to 4 or u is equal to -1. And now we have to do our substitution back in terms of x. So u was equal to ln of x, so which means we get ln of x is equal to 4, or ln of x is equal to -1. Now using the definition of a logarithm for each equation, we're going to get x is equal to e to the power of 4, or x is equal to e to the power of -1. And since both of these are positive numbers, both of them are valid solutions. So now it's time to recap everything that we covered in this video. We saw an example where the entire log is squared, in which case we had to check for both positive and negative roots because they might both work. We used the change of base rule to rewrite logs in terms of a common base and then solved it like usual. We saw how some questions could have something like a hidden quadratic equation in there, and that using a substitution will make things look simpler and easier to work with. And lastly, even though we're now on to intermediate problems, the definition of a log and log laws are still what we depend on to solve these questions. And now it is your turn to give this a try. Can you solve this log equation on the screen here? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on solving log equations in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.